Hello and welcome back. So in the video 03, adding more variants, we basically finished off by adding a model B and one material variant. So if you look at the network editor here, you'll notice it looks a little different. There's nothing different really about it. All I've done is I've just added some network boxes around to partition off the different areas. So you have the camera area, the geometry area, which includes the floor and bringing in the spinning asset, moving it to the ground, adding some reference balls and constraining those all to the camera as we've discussed in the previous one. And then we add the lights. I've moved the background plate out here a little bit, and then we've got the render settings happening down here, and then finally we've got the tops and the bash comp. Now what we did in video 4, a bit of comp in Nuke, we will do a bit of comp in Houdini. We'll do exactly the same thing coming up in here, and we'll do that in another video where I just recreate what I did in Nuke, but we will automate everything that we couldn't do in Nuke using Copernicus and TOPS. So it's a quick sneak peek of what's happening in this little bash comp thing here. So just pulling back again, we've just tidied up the network, and then over here we added model A, as you can see, and model B, and you may notice, hello, there's an A pose 01. I had a thought it would be nice to take one model, if you remember this guy, let me just quickly get this guy up. I keep cutting him up for some reason, so I keep adding a clip node in here in different areas just to kind of look inside and things like that. So the clip's a temporary thing, but if you remember, we created our proxy viewport geometry, and now our render geometry is kind of part of the component builder. I decided to add a Vellum setup so I could create another posed version here. Again, I've cut him up a little bit, and that's just totally optional. I think I was just clipping on top of an existing clip, so I created a posed version. So what we're going to do in this video is just discuss a little workflow for just kind of creating an alternative variant, geometry variant with a different pose, mainly because I don't have a rig yet, like an Apex rig or anything like that. So I thought I'll just do some stuff in Vellum. It might be interesting to get a different shape out and see this guy rendered. So if we quickly take a peek at how all this works, and I'll just come back out. Now bearing in mind we've only got like you may notice material library here is now being shared between these two, and I'll go through this a little bit more in detail to show you there's lots of flexibility within this setup. So they all just have one material variant, like one texture set. We might have more on disk, and we'll go ahead and just apply those probably in the next video. But we'll talk about the Vellum setup in this video, but I'll just give you a quick peek now. If we come back down to the bottom, and because we've opened Houdini for the first time, I'm going to generate the static work items, and you may notice there's only 3. So if we view the end of the network and we make sure this set frame range from playback, set frame range drives playback is on, and then we can now go to the render settings and it will pull in the camera, and that's mainly because the render settings are here and it is using the camera that we asked for, which is this dude here, which is this guy up here. So I also just then will, in a fresh Houdini, I will just check I've got the render settings node in the viewport. It should be fine, because if you set the render settings, it will respect the render settings here, not the viewport settings. Now default probably will be render settings. So if you see viewport settings, it's not using your render settings, and it will render from within the viewport as we discussed. And if it's default, it will just naturally go to a nominated render settings that you've said is default. And I think that is somewhere somewhere on here. There is a way of, it's probably like looking at me right now and I can't see it, but there, set as default render settings. So if you had multiple, you could set that. So basically the render settings here and here would be the same, but I always explicitly go to that one. Right, so You may notice there's only 3. If we switch to 1, and then we switch to 2, switch to 3, it's the same light rig now. The guy's still spinning around and everything, but I've just updated this a little bit to be a bit more modular. So if we go in now, it's got fancy colors, and I've got the wedge HDRIs colored yellow to kind of mirror the lighting setup, and you can see you can merge them together. So I should rename this to HDRI, please. In fact, I'm going to call it maps. So what I thought would be easier would be to just list like kind of the ones that I'd like to see every now and again. And because before we had a massive list, and you could say, oh, just give me out of this list of 2, give me 2 or give me the 1, and then merge them together, and you can choose and just layer them up. So if you're not interested in rendering 5 light rigs for every single geometry variant and material variant, then I don't blame you. It might be a bit overkill, but I just thought I'd show you this. It's a bit of flexibility in there, so you can just merge them in. So we have just updated this, so now we'll have 1 wedge count for the garden, and we'll have 2, we'll basically wedge through these 2 from Cave Academy. So I won't be shipping these, but you can go ahead and check out that website. It's fantastic. The wedge material, you could do something similar. We only have 1 material, so I'm just wedging 1. And then the wedge geo, obviously that's red to kind of simulate a MaterialX color. I don't know. Wedge geometry. So we've added, so you need to know your geometry variant names. So just be careful they don't change. But this is your way of just kind of quickly wrangling all your data together. So I'm going to wedge all 3 of these, and then it's going to render. So this is going to fetch the asset USD render. So if I hold Control and click, this is the node it's referencing. Okay. If I press this, it's the node here that's kind of driving this. So I'll just dip back into the TOPS graph. Then you'll notice this gray comp, HDR comp, and occlusion comp. That's kind of going back to the nuke kind of thing I did, where I rendered out the creature on a grey background, and I rendered it out on the HDR background, and then I did an occlusion one. This is accessing something in Copernicus later on, so it's going to do everything for you and comp it and create an EXR of that, even a contact sheet. So we're going to talk about this bit later. So let's see what happens now if because we've gone in and modified, you will always have to dirty and generate new static work items. So now we'll be presented with different light rigs. You can see this light rig's very, it's got a very big soft light, so it kind of looks like there's nothing there in the background. But you can kind of see we've got this other guy here coming in. So we could take a look quickly at him, just fire up this Karma. I've rebooted machine and I haven't loaded Karma yet, so it will take a few seconds to initialize. You can see the background plate still shining in and things like that. I think I tweaked the background plate a little bit. Now the thing I'm missing, and I probably could do this in Nuke, is the background plate is coming in at this lat long kind of thing. So I've just temporarily scaled and transformed this. But this might be you might want to change this per HDRI, so we might have to get a bit more inventive in how we do that. What I mean by that is if I middle click on this, you can see I've got this studio map. If I click on this, and I click on this, and I find the garden one, this one that I shot in my garden, you'll notice it looks a bit more like it's still got a bit of distortion, but I've just scaled it in manually. So it's not critical, but it's just something, you know. But what I'll do in the future, I will try to synchronize the rotations, the backplane, and everything, and what we're getting comp as well. So it just makes a little bit more sense. It's quite forgiving, really, but you know, if you're looking at the background and the HDRI is not orientated, it could throw you off a bit, but it is a look dev scene, so I'm not too fussed at the moment. So here is the monster A, and I tweaked the shaders a bit, but again, this tutorial is not about that. We're going to go and look at the Vellum setup now. So how did I do this? So I'm going to press Shift R to stop rendering, and then we're going to just jump up here. So I basically, when I'd finished with this guy, I thought, well, why don't I just pull this into a Vellum system? So I used a SOP modify. Now there's going to be a lot of stuff in here which is overkill, but this is because it's a template for a sim rig that I will be using in a lot of upcoming tutorials, where we'll be using more complicated character than this. This is just a two-piece, isn't it? It's a fascia and a skin minus the Hannibal Lecter head removal thing. But there's no separate eyes or teeth or anything in this yet, so it's quite simple. And to do a Vellum setup would be quite simple, but I'll just show you a quick template. So first of all, we've got the control null here, and I define like which stage of my pipeline I'm in, assets or shots. That's just going to retain a location, the department, and if I middle click, it's going to grab monster, and I'm going to grab the name of my CFX working environment. It's not really CFX, but that's why I'm using it for modeling. So I could change that to modeling if I want, but I'm just going to work in here, and that's going to get like all of this is going to be saved. So anything I do in here, all the information will be saved with this tagged name in there, so it's kind of clean. So I could create one called CFX monster A02 or B or 1 or 2, and all the information that's created from this Vellum network is going to be nicely organized on disk. So it just keeps it clean. So the first thing I do is I'm just grabbing the input. So whatever, if I press U, whatever is coming in here in the SOP modify, I'm basically making sure I bring in the proxy and the render purpose, and I'm unpacking this to USD, from USD to polygons. Okay, so that's pretty much what I'm doing, and I'm just setting the import frame, and I'm setting this traverse through gprims, which I think just basically means just load any geometry. So if this USD contained other things like materials and rigs and stuff, it won't necessarily pull that data in to this SOP network anyway. So I don't think there's anything else worth talking about at this point apart from what's inside. So this is the import. So the first thing I do is I just make sure I'm not ghosting outside of this environment, and I'll look here, just go into wireframe, and you'll see you get this kind of thing going off. So what you're looking at here is you're looking at the render geometry and the proxy geometry like in the rest position as it currently stands. So what I've done is I've just made sure that this sits on the ground, because usually maybe the original model was not sat on the ground when it was published. It was like at the origin and stuff. And this is your choice to do whatever you want. You might want to instance this onto a point. I don't know, it might be not a monster, it might be an asteroid or something that spins around the center. If it's a tree, you probably publish this with its base at the at the origin. So if you instance this, it would always be on the ground. Anyway, I just push this to sit on the ground, and then I've done some temporary animation, and I'm just gonna like basically just nothing fancy. I'm just gonna use this to drive the Vellum sim. And then on this side, even though I'm gonna say this is going to the rest position, and then I'm gonna split out it basically this is just a setup for like main connecting to animation and stuff. So then I'm going to export the high-res rendered rest, and I'm going to export the high-res proxy rest, and you'll notice these little brown lines are indicating it's being used elsewhere. So we'll be going backwards and forwards. So this area will just kind of like bring in the main thing and apply a bit of animation on top. This setup's quite basic, by the way, so I just kind of partition things off like import, and maybe I'd add pre-roll. You can see I'm going to add some pre-roll and restaging to cancel velocity, but you don't really need it in this is just to kind of drop the creature. So I'm going to bring in the rest, and I'm going to work on my rest position, not on my animation position. So I'm going to build the SimGeos, and you might think, oh, this is a bit like overkill and partitioned off too much. Could do this in 3 or 4 nodes, and you probably could, but the way I'm doing this is this creature I'm going to be building a template later on which will allow me to grab bits and bobs off of these guys, so when I get a more complicated one with eyes and internal bits that we need and teeth, then we can just list it cleanly and just work on it from there. So I'm going to go into this sub network in here, which is going to try and process. I'm going to press escape and jump in. So from the top we bring in the geometry. Let me let this just, and basically what this is going to do is generate a triangulated skin and a tetrahedral mesh for the internals for the Vellum soft body kind of dynamics. So this bit's one of those things that you would spend a bit of time trying to get an optimized simulation mesh or meshes. So this this setup I'm showing you now is pretty much how I did all. I bring in 3 USD assets and have them all interact with each other, or have the same USD asset like copied over into instances of itself. So it'd be like monster A01, 02, 03, and then I would just put them into a Vellum system and have them jump around and, you know, whatever I do, hit the screen or whatever, and then I would render them out and apply random material variants that are stored within the SD. And the nice thing about it is once your Vellum simulation's done, you can actually randomize those material variants that exist already and stuff. You can go in and add a completely new material if you want. Anyway, so we bring the model in, and it shouldn't really be clipped like I don't think this is going to be particularly helpful with it being clipped. So I'm going to quickly pretend that never actually got clipped here. So I'm going to stop clipping him because I need like a watertight volume to do this, and I'd have to cap this, and this isn't the real design of the creature. So unless I just capped it here, well, let's just leave it. It should be a bit of fun. This is just a preview thing, but as you can see, if I go back into the build sim geo, when I subdivide this, I had a polyfill to try and do some very dirty kind of filling of this. Now all we're going to do is simulate this as a fatty volume. We're not going to have any kind of internal muscle moving around or anything like that just yet, or anything fancy. It's just going to be a basic Vellum drop. And the fascia, we're going to bring that along for the ride, but it's not going to be simulated. So be interesting to do it this way. So I'm going to do a VDB from, let me think, why is my viewer doing something weird? What did I have set up here? There we go. I was looking at something with no lighting. So we've done a VDB from polys, and then you can go in, and this is like just me reshaping this. So I just made it a little bit bigger, and this is trial and error when you're always going and looking back at your original model, which is, it is there, you just can't really see it. And then I'm going to convert this back to a polygon mesh with a little bit of an ISO offset, which just basically, if you see the ISO offset, if I remove that, it basically allows it to kind of resolve closer to the volume, so that the geometry will kind of push out a little bit. And I want that for this particular model, because we know these points are a bit of a problem. So the input again is way smaller than the new geometry we've just created. So there's the new thing, and then there's the out thing here. This is the original render geometry. So, and the reason for that, I want to just do a little soft peak. I'm going to push this out a little bit more, and then I'm going to create a thickness attribute, and I'm going to use this thickness attribute on this mesh here. And obviously I'm going to blur this because it's not very precise, but I'm going to blur this thickness attribute out to average it out. And then I'm going to convert that thickness attribute into a new attribute called target mesh size, which the remesher kind of can use. Then I'm going to remap that. I'm going to blur this target mesh size a little bit more, and then I'm going to view the target mesh size. So I should now switch over to the target mesh size. It's going to be difficult because the values in this are really quite small. So if you look down here and we hide all and we go to target mesh size, you can see they're quite small because this is going to be the maximum triangle size and the minimum triangle size here. So I'm basically going to try and remesh this in an adaptive kind of way and kind of have larger triangles here and smaller triangles to try and conform my sim mesh or my triangulated mesh a little bit closer to the original shape. So that'll become more apparent when this thing is triangulated. This is the hefty part. So what I tend to do is I test out different resolutions, and then I bake this sim mesh down to an OBJ to a BGO. So it doesn't contain any attributes that are for Vellum. It's just the actual sim geometry. So it's a very clean sim geometry. So if you look now, you'll see that it's been remeshed adaptively. So it's a little bit larger around the well, it would have been much larger if he had a head, but obviously I'm being silly and I'm cutting him up for some reason. So this doesn't conform completely to the original geometry. It's just a little bit off, but this is trial and error where you'll be trying to get this to work. So our new simulation geometry, this orange thing, is a little bit bigger, which isn't necessarily a bad thing because it just means that your original geometry, so this orange thing is the thing that's going to move around and be simulated by Vellum, and then the white mesh is your original geometry that gets rendered and has displacement on it. So sometimes I take the high res displaced geometry and I conform my sim mesh to that. So I know that basically when lookdev have calculated all the displacement offsets on the render geometry, my sim mesh conforms to those displacements a little bit as well. But that's only for really super high res detailed simulations. But for now, this is kind of like a cage around it. And then I take the original geometry that you can see, this subdivided geometry, and I'm going to ray back my simulation mesh onto it, but not completely. So you can kind of conform and choose how much you want for that to be like caged around. So we've got like a sim geometry, which isn't the highest res, but it's just for a drop test. So it's nothing too crazy. And then we'll create a tet conform. So if you're not sure what a tet conform is, it's going to fill this up with tetrahedron. In fact, I'll just do it and I'll show you. I'll let this quickly calculate, and then we'll cut him in half like this, and then we'll try and turn off the attribute here. So it's going to fill him up with these triangles. So if I move this clip node, this is just for visualization where you can clip the geometry via a cutting plane. If I move through, you'll see that there are these grids in here. So if I view the points, you can see there's lots of little triangular shapes in there. So maybe if I go to this smooth wire shaded, you can see. So because we've conformed based on the thickness and the target mesh size, there's smaller triangles in the areas we need it and larger ones. So we're going to get more points of deformation in those little things and more kind of volume preservation and structure in the larger ones. You may notice on the inside the distribution of the triangles or the tetrahedrons are not very consistent. This is optional. You can actually create a volume out of your geometry and scatter some points on and clip those points, or just basically target the points, and when you add the points in, you can increase the resolution of your tetrahedrons inside. So, and that gives like more points of articulation. It might slow your sim down a little bit, but it doesn't change the skin, so it just gives a little bit more kind of structure on the inside. So that's an option you can do. So if you need to get more kind of deformation and stuff, you can do a lot of cool stuff with this. So I kind of just left that in. I don't think it's really affected the sim too much anyway. So yeah, so we've got like a simulation geometry. Here he is. So I'll just go back to my smooth shaded and select this guy. So we've got this simulation geometry, and that just represents the skin. So we're not actually going to bother with the fascia because we don't really need to do anything with this. In future tutorials, that'll become more useful when I might animate the fascia first and have the body follow, or they both might be interacting, or the fascia, the red thing inside, could be a volume of guts or blood and stuff. So the one thing I've learned is keeping very organized with the data you're feeding into Vellum, because this might be one of many Vellum meshes that you use. So I'm just creating a name, and I'm calling this Monster A Skin Tets, and this name's been derived from this subnet name. So I just know what this is called. And then I'm gonna clean up any existing groups. And you'll notice you'll suddenly get these like groups called interior points and surface triangles, and they seem to have appeared, if you kind of middle click, they seem to have appeared when we created this this tech conform. These appeared then, they weren't there then, and that's quite useful because it'll give you the interior points, so the surface points and the surface triangles as a primitive, and the other two are points, and that's really useful. But when you've got a lot of different bits, and you might have many different creatures, or you might have Monster B in the same system, and you do the same workflow, those groups will become the same group, and they can be useful as a collective, but I like to partition these groups off. So what I did is I created a temp name here. Primitive, isn't it? I created a temp name by promoting my existing name into a detail attribute, and then I renamed the surface triangles, the interior points, and the surface points using this little bit of H script. I think an expression. So I'm using the details of from this node. So I'm basically querying this, and it's going to create these group names. So now these triangular group, these names are now named after the thing they belong to. So it's just easy to identify. And that'll become more apparent later on, and this was trial and error, because this is something, if you were just going to drop this in Vellum, you wouldn't even think of doing this because you're just using one piece. But because this is a much larger structure and a much larger setup that I dropped down for doing quite involved CFX, then this is just something that I do, and I just catch that. I then copy a path back, and I copy this geo ID. Now we don't need to worry about these too much. This is for like later on when we've got lots of bits and bobs. So, but you'll see this appearing in some of the more advanced Vellum tutorials, but because it's a template, just leave it in. It doesn't matter. So if we're going to jump back up, we have come out of this node, and we've come from taking our original render geometry and just having a nice little place to dump simulation geometry. Then I'm going to cache it out. Now, it isn't this linear, broken down sometimes. Sometimes this goes straight into a Vellum, and I just play around with it and make sure that this sim mesh isn't too heavy to maneuver and stuff. But this is the way I'm working at the moment, so I would save this down. So because this is linked to a controller that's going to bake this down to the location on in my project structure. So if you remember, the monsters. And because we're still in assets, and we're under modeling, I'm going to go to assets, and it's the monster asset we're working on. And then I've put it into data, and I think the department, I branded it as modeling still, which it's up to you where you want to dump your rubbish. And then it's geometry, and then you should see this monster CFX monster AO1, which is the SOP create, the SOP modify at the LOP level. I'm dumping all my data in here. I'm not dumping it in here, I'm just dumping it in here for now. And then you'll see that it's got this DC monster DC MA skin text. So you can name these as crazy as you want. So that's just me saying Monster A skin sim. So I just know exactly what this is in this like SOP world, in this Houdini world. So this is because you might have a DC just stands for disk hash. It's just my thing. So you might have Monster A fascia, Monster A teeth, Monster A eyes. Then you might have Monster B, and it could get quite messy. So this is where I'd build my sim geos. So that goes to disk, as we've just discussed. You may have noticed a couple of other things in here. You may notice this and that. They're on the way. We're going to talk about those in a minute. So the next stage is I configure the groups and the sim attributes. So again, I just bring things in with object mergers and keep them in partitioned areas, so I could kind of in my mind partition things off. So hopefully it's kind of like you import, you deal with your animation, you pre-roll, you build the sim geometry, and then you configure the groups and the sim attributes. So my groups for my Monster A, I've done stuff in here. Sometimes it can be quite elaborate, and sometimes it's very simple. All I've done is group the all MA groups like that, and then I've grouped the velocity groups. So I've just created a group to grab everything, and then it's probably not useful this because it's just one object, but then I'll have a group called velocity, so I might use this to throw velocity on those points. I'm actually going to use that as an attachment group as well, so you can get very precise with your groups. And I like to just have all my groups here because they're the groups that will essentially be the things that either painted attributes will be biased off of, or constraints will be biased off of those groups as well. And then another subnet, I do an MA skim sim attributes, and I create a rest attribute up here, which is just so there's a rest attribute for my sim geometry before it moves, which is kind of essential for a lot of things later on. And then you can go in and start adding your Vellum constraints. So I've just added some stretch stiffness here. Again, that's trial and error, where you just kind of playing around with it. But you can visualize the stretch stiffness here, and it will, if you click this and this thing is also active, you'll see the stretch stiffness, and you can also see that the stretch stiffness is a point attribute. So you can see, let me just hide everything. You've got the stretch stiffness here, ranging between 7 and 10. I find it, without creating a custom visualizer, it can be annoying to see exactly what those values are doing in the viewport. So what I tend to do is I create a color node. I know there are the attribute visualize thing here, and you can set that up to be ranged, but you can't reference copy those values into here and have them like mapped to an image, to a color. And what I mean by that is, if I come in here, you can see that this is green. If I middle click or double tap or whatever, so I'm actually left clicking here, this is linked to this minimum, and you get the idea, the max value is linked to that max value. And I put it through a color, and if it's still red, it's because you're viewing the visualizations, you're viewing the stretch. So I right clicked on here, you're viewing the stretch. So if you turn that off, you're viewing your stretch remapped in a pretty color. Whereas you can do that with the visualize attribute, but you have to keep manually updating these. So with this, if I change something, then those values are still kind of like mapped the same, and it's kind of just showing you where your values lie. So you can see the value of a range of 2.39 is going to be in this vicinity, this color range, you can see here. So if I right click to previous value, the other way you could do it as well is maybe you could press S, and because it's a point attribute, if you go and right click and say point and press S, you can select a group of points. And then I think in here you can do something where you can show the selected points, and you can see the attributes, the value on the point as well. So you can kind of query it that way. So you can kind of, might not be useful. Just don't forget to turn that off because you want it to show all. You can press escape to come out of the selection mode. So this is one of those things that can be quite an elaborate subject about maps and how they work in Vellum, but I'm just showing you. I basically just added one, then I added some friction. So I've added a friction and a dynamic friction using a wrangle node like so. So I've got a slider. So my friction on my solver is set to 1 for both the, I'll just jump up and show you. I'm just going to skip through this bit and move down to the solver here. In fact, when you do that, make sure you're at the frame. Make sure you're at frame 1 because it'll try to evaluate. My solver friction is set to, it will be in here, 1 and 1, because it's a multiplier. So I just globally set my friction on my objects, my colliders and stuff, and that just stops that from being unpredictable. Sorry, here, this is the one, static and dynamic. This is the friction for the invisible ground that we're actually going to use. So you'll notice there's no collider in here. I'm just going to use a ground, but we can put your own stuff in, which we do later on. So just going back up to where we left off, we finished adding some attributes on. So we've got groups and attributes, and then I add some Vellum constraints in here. So again, the only reason I'm using subgroups is because subnets is because I might actually have something for the eyes, or I might have another monster, and I want to keep everything network boxed and clean. And you'll see when we get a much larger scene how this this way of working is just kind of keeping it a bit more organized. It's just my way of working. Do what you like, you know. It's up to you. Long as you can get your job done. So the skin tet is Vellum constraint. So we're going to create a tetrahedral stretch constraint. Now I will go into Vellum a little bit more in the Vellum series we do using these assets, so don't worry too much about that. And there's plenty of documentation, and there's plenty of really good like tutorials out there on YouTube to look at how to use Vellum and stuff, and I'm still kind of getting into it a little bit as well. So it's just a fantastic system. So we'll just quickly assume you know what a tetrahedral stretch is. Essentially, it's going to create a constraint between each point, and it's going to kind of create a primitive line that's a constraint, and it's going to try and maintain that volume basically. And because it's going to be a little bit more rigid around these larger areas, and it's going to have a bit more point of articulation or more freedom to kind of deform on these smaller areas. And you can define that with a bunch of parameters on here, and you can bias it with maps. So you can see I'm scaling by both, and I'm scaling it by the stretch stiffness attribute that we created earlier, which you will always be able to see just by coming in here and activating the, going to a wireframe, and then click on this, and then click on that. You should be able to see it. Not sure why you can't. Or maybe this wasn't, maybe I need to actually select the node. Yeah, so it's not particularly useful because it's red because the values are kind of crazy, but at least you know it's there and you know a way of visualizing that as we did earlier. The Vellum pack, it just packs together the constraints and the geometry associated with this Vellum for later on if I need to do anything else with it. So essentially that's what this is. It's just a quick way of just kind of setting groups, making sure I know what the names are, setting attributes, making sure I know where they're going. I tend to create attributes, painted attributes, as procedural as I can. I don't paint on the skin because, as you know, things are changing all the time. And then I will only really commit to painting on the skin painted attributes when I know the model's really approved. And then I will actually paint on the render geometry as symmetrically as I can if need be, and then transfer that across, and then just hopefully have a buffer in case something changes. But for now, you can use things like the length and the thickness and bounding boxes to group things procedurally, which we'll demonstrate later on. And then we've applied the constraints. So we finished in section 3. So as you can see, we're kind of like moving through in a very, very, very weird way. So this bit's work in progress, and I think I've got a better way of doing this in the Vellum series. So I bring in the simulation geometry, and I bring in the animated geometry. So this is the animated geometry that we did. And you can see I've got this pink for animation. You can follow the wire going right back up. So this is the animation. So bearing in mind, this point, and up to this point, we've been working on the rest geometry. So we can make sure everything can be symmetrically dealt with. So what we're going to do now is bring in that simulation geometry from the rest and unpack it. And I'm going to group all the SimGeo and I'm going to group all the constraints. Okay, so that's just for later on. You might not need it, and then I'm just going to merge these back together. And then I'm going to take the animation here and I'm just going to set it back to the rest position. And I'm going to point deform my SimGeo into place so you can kind of get oops, we got the visualizer of the thing there. So we've got this going off, and then I'm going to split this back out and put it into a pin to target, which is driven off of this. So the pin to target is going to be the thing that like allows the Vellum. This is not a Vellum sim, this is just rigid geometry, rigid simulation geometry, but it's going to allow this to be driven into place. It's a very basic setup. So yeah, so then I'm going to output the again, it's my way of configuring constraints and relationships of constraints that might be associated. So we might have eyes constrained to the body and teeth, and then later on the teeth will be rigid and there'll be a shape match to kind of maintain that rigidity. So yeah, so we would do that. Then I will bring in for simulation. So I bring in the SimGeo and I bring in the constraint geo. And then the cache stuff, it's optional, depends how quick things are, but I sometimes like to cache the input a little bit here. And you can write this out as well, but you'll see how that's not exactly real time. Actually, where did my FPS counter go? If you press, you can see how interactive this is by going to guides and then draw the FPS, save as defaults. I don't know why that's, maybe because I made a new desktop. So you can see this is now, we're obviously running at 24 frames per second, I guess, in this project. By the way, always check your simulation FPS. So that's rather quick now. So that's what's going to be going in. So what you want to look out for is this at real time being like this, because Vellum's going to be just as slow as this, plus the slowness of the solve time, basically. So you want to get this as optimized as possible. And then for the Vellum constraints, because the constraints all initialize at this position, and I'm actually kind of bringing in something that's not very efficient here. And this is, I'll probably fix later on. It's not very efficient, look. And this will just keep playing this slow. So that means I'm feeding that slowness into my Vellum solver for the constraints. And if you look, it's not doing anything, but it's really slow. So I think I've got a quicker way of doing this now in the Vellum series. But at the time, I just did a hold. Now this could be useful, but if you're dynamically changing constraints, it might not work for you. But if I hold this now, it's going to go back to being quicker than real time. So there we go. So next we go into Vellum. And I've just set the start frame. I haven't really changed much at all. So I've got like 4 and 100, very basic. That might be overkill. Can just try everything at the defaults first. You know, it's probably going to be good enough, really, because we're not doing anything rigorous for Vellum. In terms of forces, I'm not doing much. Set your memory. This is in megabytes. So set your memory to what you want. I think I've got 128 gig of RAM on this machine. Yeah, so I haven't changed anything in here. And then inside, what I'm doing is, some of these are disabled, but they're not actually in use. But I'm doing a pin to target constraint, which is a way of animating the values of a constraint, which we don't actually use. So what we've got is a Vellum constraint properties, and it's linking this. So this is a reference copy to a group that's called skin pin to target constraint. and it's setting this to 1. So that group is actually coming from, you see all these like little brown lines. I should be able to like find it just by doing that, but it's coming from in here, and it's copied. I copied this, I used this group. I'm going to press U and then go back down to my sim section, and then if I middle click, you can see I'm using this. Well, this is actually what this group does. Sorry, my apologies. It's referencing the constraint you want to modify. My apologies. So what this is doing, it's actually finding this guy, this skin pin to target constraint, which I think we skimmed over by mistake, so I apologize for that. So I added a constraint, and you can see the constraint, and they are the points. The points are coming from a group called Vellum groups, which you can find is basically this. So the reason it's a star is because in the past I've had different bits and I wanted to grab them all. So you can group names and you can make groups very logically and have constraints apply to multiple groups by doing wildcards or just having the groups in twice like that, or whatever you want to do. So that's quite nice. But you get a visualization here of the guide geometry. So that's what that is. Now this isn't actually being used, so it would work with or without. But if I was to animate this, or if I press play now, this vellum would all hang, but it would be pinned by those points. But those points are actually in motion anyway, so I'm like gracefully moving him down to the floor. And sometimes I throw velocity in at a certain frame, inject velocity, and then I actually kill if the frame is equal to 1020. I'll start adding in some dampening ratio of 10, so it's just going to dampen it down quite a lot. So there's tons of stuff you can do in here. So just bear that in mind. You'll see this gets quite populated later on in things. So the simulation is ready. So there's the floor here, this blue thing, and I'm enabling the ground position is set to 0, and I'm enabling this ground position. Normally I have a collision section coming in here, and that might be coming in from your LOP network, and you'll apply attributes and unpack it all and bring them in here and optimize it. But for simplicity, I'm just gonna move this guy down. So if you remember the original animation coming in, which was this guy, I think I'm actually selecting the solver as well here. That's why I'm getting this crazy thing going off. And I've got a viewport. This can be a bit confusing, but if you go labs, reset view, yeah, I had some weird view. You can just get a feel for it when the viewport gets a bit glitchy in Houdini. But there's the original animation, and we are pinning it. The simulation image being pinned in the middle, it with a volume, like a spherical volume. So we're going to let this be driven by that, and everything else should just fall to the floor. So it's a very, very basic Vellum sim. So, and we've chopped his head off, which we don't have to, but we'll do a version with and without. So this looks like it's falling, but really it's being guided down. So you'll notice the body slows down and then just basically stays put. I could have just dropped this, but then you might have got like a lot of secondary bounce. And this is just a very cheap way of posing the creature like you saw in the previous render. And you can do as many of these as you want, and if you're familiar with Vellum, you can get in and get fancy. I just did this, and I'm going to just pick a frame I like and use that as a new pose. So the next thing I'll do is I'll just cache this out. Now you notice this blue line is basically Houdini uses your system RAM and tries to do that. So if it runs out, the blue line will disappear, and then when it gets to this point, it'll start solving again. So if you've got enough RAM, you can kind of get a cheeky preview of this quite quickly here. But you more than likely should cache this down. So I'm going to DC sim, and again, this is referencing my controller. So I know that all this is set up here, if you remember. So I'm just going to pop that to disk, and it's going to be super quick because the simulation's done. So all it's doing now is just preparing this for writing to disk. So we've got like this simulation now coming in and just dropping. But this simulation is still simulation geometry. Let me press escape. This simulation is just the simulation geometry. It's not the render geometry, and it's certainly not USD geometry or anything like that. So this has gone to disk and it's gone to DC Sim. So you've seen the MA skin test prep thing goes in there, and then you can see the DC Sim goes in there. So I'm just keeping organized, and it's data tied to on the project. It's tied, as I mentioned, on the monsters project. It's data, it's under assets, it's under the monster asset, and it's data modeling geo, and then it's like we're just doing a kind of an internal SOPS working area here based on the SOP modify at the LOP level. So out comes a simulation. Now sometimes your constraints are very, very important for doing things. I used constraints to do I remeshed constraints to look like guts and stuff and things, and there's loads of stuff you can do, but we're not actually going anywhere with these. We're just going to take the sim, and now we're going to do a post sim cleanup. So this bit can get quite big and messy depending on how organized you are and what you need to do and what's happening. So we're bringing the sim geometry, and I'm going to, this is not a shot based workflow, by the way. I'm just dropping this, so there's a lot of things that are missing from this that you would be required in a shot, which is coming up, don't worry, in the tutorials that we have later. So Vellum will spit out an absolute ton of stuff, which is quite useful sometimes, but I know what we need, and basically for this I'm just going to strip this back. So I've stripped it back to just be color, position and rest and the name. And then I'm still keeping all the groups because I haven't done anything yet. So you can see all the groups. I think in future tutorials, I actually name all my groups that I create a underscore CFX sim, so I can kind of identify that they are kind of a CFX orientated group, because sometimes groups get created and if you're not organized, they are difficult to remember what's happening. So the first thing I'll do is I'll remove unused groups, because I know if they're unused, they're probably not useful to me at this point. Not always true, because you might use that group later on, but going to remove the groups. So it's going to pop out unused groups. Now we know we've got all the points in this and all the sim geo, which is going to be the same thing, but this will allow me to, well, these become more apparent later on in shots. They're just there to use if you want, but these are technically the same group. But there is a reason I've done this. I can't remember. You've got the interior points, the surface, and you've got triangular points. So we can keep those maybe for cleanup work later on. So you might be bringing in lots of bits and lots of creatures, and this is where you start partitioning off and keeping your namings very tidy. In our case, we don't need that right now. So if you've got other bits, you would split them off here, and that's where these groups come in useful. So I might have had a unique group for a unique object. We don't have any other bits because we know, well, we don't have any other simulation bits in this stage. We just have this bit. The bit you see poking out, the fascia, we're just going to point deform it. We're not going to simulate it for now. We don't need to. So in order to do that, I'm going to run this through a quick delta mush. So delta mush will basically try to preserve, it's going to be minimal here. I think you probably won't even notice it because it's not that bad, but it's going to try and preserve the original structure of the model. So if sometimes some of these simulation areas here, these smaller bits which are a bit low res, they can sometimes, if you've got low velocity or high low samples and high velocity or whatever, you put the solver under strain, these bits can sometimes degenerate in the solve, meaning they don't solve properly and they can get a little bit messed up. So with and without, it might not look any different, but it will try and maintain the original position of your rest simulation geometry. So it'll try and look at this and go, this is the shape it should be, and then it'll try and retain that with the delta offset with a delta mush. Very probably overkill, but for that to work you need like a frame that holds. It needs a rest frame here, reference geometry, and then the actual geometry. Then we're going to point deform, so we're going to revisit our rest position. So here he is. This is the render geometry, the render purpose that we have coming from Solaris. If we zoom out he's been brought right back up from up here. So that'll be the same thing. So this at this point in time is the reference geometry. It's not animated. You might have animation coming in a shot-based workflow, but we've added animation ourselves here. So just picking off where we left off here, if we come back down to the post-sim stuff here, and we apply this point deform in here, now you'll notice I've got something called GeoID. It's not actually going to, I don't think it's going to do anything at the moment, but if you've got geometry with lots of different bits and stuff, you can identify how to individually apply the point deformation to this. So you could actually have one monster with different bits, and you can do it all in one point deform. It's up to you. You can do multiple point deforms. We don't really have anything too complicated here. We just have this flesh colored thing. But as you can see, the head has been point deformed as well. So this head is not actually going to be dynamic, but the inside would wobble with. So it's just a cheap way of doing it. But if you wanted this to simulate in here, then you could do that. And if you didn't clip this and you had this simulation geometry, this original pink geometry, which was this guy, if this wasn't clipped, this might have a bit of secondary motion, but it's for a still, so I'm not really that fussed, and I wouldn't normally clip it. I'm just showing you that it's quite forgiving for certain scenarios. So the next thing is I go through another delta mush. It might not look completely apparent at this stage, but don't worry too much. I'm a bit shocked that that looks could be the original. I wonder if the original geometry was that messed up at the ends. When I revisit that, I'm going to look at the rest model and see whether or not that is. Oh, it is. Yes, it is actually pretty bad geo. So just bear that in mind. Your geometry. Oh yeah, when we retop this, we had problems with the edges. So remember how problems always come back to bite you in the butt. Well, there's one. It's not a problem because you probably won't see it when it's rendered. But I wouldn't let this go in product. I'd be like trying to get better topology than this. But we've actually done a decent job in CFX preserving everything we need here. So just bear that in mind. The next thing is totally optional. I bring in a grid to represent the floor. This is usually collision, and then I'm just going to remesh to get a few more points. And then I made like an intersection fixer, which is probably overkill. And it creates a group basically called intersect smooth group. So essentially what this does, it checks for the thing in this particular direction. So in the Y direction, it's going to intersect, and then I'm going to group expand the group that this creates. So this creates a group basically called intersect smooth, and then I'm just going to look at where this might be intersecting that floor, and then I'm just going to add a smooth onto everything apart from the stuff that's not being intersected. So essentially sometimes this can help sometimes with things moving up against glass and stuff. So to visualize the fall off, this is kind of like fall off here, just hide the grid. You can see where it is. So I was using this when this thing was like meant to be hitting glass, and I was like post sim flattening this a little bit, and I was thinking about using that in the shader. So when you put your thumb against glass, and if you look at it from the other side, you can see how it flattens perfectly, and you can see how maybe things change color. And that was just toying with that idea, so that will be in another tutorial. So this is kind of, I left that in so that would be quite interesting. Maybe it's useful to just get the ball rolling with that conversation. So there is the enable fix to either bring this fix in or not. So if we activate the fix on and off, it kind of like pushes it up a little bit, so it conforms to this ground here. and it's quite forgiving, I guess. The other thing I've noticed as well is when you have like an object hitting glass, it's hitting the floor in our demonstration, but it's hitting the floor, but in some of them I've had him like hitting glass, and when it's all flat it's perfect, but the displacement is still like pushing outwards. So if like you had like warts and stuff on this thing and they're protruding out, if it was a normal map it might be forgiving because normals don't breach the surface. They're a light trick of the light to give more detail, but if it's a displacement it would subdivide the geometry at render time and push this out like into little spot areas, like little lumps. And if you wanted this to hit the glass, these might come through the glass in the displacement. So what we might end up doing is kind of setting up something where we send an attribute back to lighting and lookdev, and they can negate the displacement that much, maybe using that value or something, and flattening this out or something like that. But that means there's a bit of a dependency between CFX and lighting and what's in the asset, but that's fine because you can always store an asset of your name. So you can always store an attribute, like this could be called fall off. It's very descriptive, isn't it? But that attribute could be given to lookdev and they could do something with that attribute, and it's a bit of back and forth, but we'll cross that bridge when we come to it. But that's kind of what that's for. We don't need it in this situation, so I do apologize if it's going off a bit. I do a group cleanup, and then as an option, again this is a bit tongue-in-cheek, but I bring in the original model, because this original model has come right up from the top. If you can follow this guy along, it's come right up from here. Nothing's been like added at all. It's just been put into the rest position. So this is exactly how it came out of Solaris. If I press up, this is like how it came out of Solaris and how it's gone into Solaris. So I'm going to take this. There might be issues with this in a more complicated situation, but I'm going to take this. I'm going to take my sim wrapped stuff, and I'm going to basically blend shape the original back on like that, so you get this, and we know that model's kind of nice and clean. Even though I've spent a lot of time cleaning up attributes, I still don't trust like this, so I thought that might be a safer way to make sure that it blends shapes across, but I might revisit this area. Then it's time to send this back out to USD. So this object merge just gathers everything I need from, and it's just out render, which is this guy going in here. So it's kind of, that's it really. And the next thing is the SOP modify will like modify whatever you ask it to modify, whatever you bring in, and we've brought in the render geometry and the proxy. But if I just send out this now, the proxy would be still always at the origin, so that might not be very useful for lighting situations. So what I've done, if I remember, is I brought in the proxy model here from the original. You could create your own, by the way, but I think it's better to just kind of what comes in must go out for basic stuff like this. I think it's easy to think about that. So this proxy model in, if I follow the line, or if I control click, you can see this is the out model proxy. Or if you click on this and then space G, it takes you to the node it came from. So we're back right at the top level and we're bringing out the proxy. Okay, so if we go back to the USD, I'm going to bring that in. I'm going to take my original geometry again. This time I could have gotten this anyway really, but I'm just going to extract the rest position. So before it was like posed, I'm just going to quickly extract. Again, this is doing it per frame, so it's not very efficient, and you could have just grabbed the rest position from somewhere else, like maybe the original, maybe that would work as well. You could just grab that in there. I think it would work. So because that is technically in the rest position. Oh no, wait, that's the I'm taking the skin rest position here. So it doesn't really matter, but maybe for efficiency, maybe that would be something you do. So maybe we could put, instead of extracting the rest position, maybe we could put that one in. We can point deform that. So I think either one would have worked, but I think this is like a little bit, if you look at the performance, it's a little bit quicker than maybe bringing in all of this and point deforming and then trying to extract the rest position. It might be a little bit slower to do. So this, you know, is probably another way of doing it. Where did my SOPS green go? I had a nice, they keep disappearing. I had this color. Oh man, I'm never gonna find it ever again. Yeah, is that gonna work? Okay. Save to defaults, and I'm gonna. Look, he's green. Right, so I'm gonna put that there and just have that as a more efficient one. So that's the alternative, I guess. So we get the proxy geometry, kind of, and because we're using the original proxy geometry, all the USD attributes are intact, which are important there. We've not changed anything really. Now normally you would you try and keep this untouched so that when it goes back out, Solaris just knows that that's the proxy geometry and it's going to go into the right path, into the right hierarchy and stuff. So what I would do then is I would take both my rendered geo and my proxy geo and I would gather them together like so, and it'll look a bit weird. There's a little bit more involved in this in the shot-based workflow, but this should work. Then I'll just cache this out together again using that kind of versioning system. So this should be fairly quick. So it's a little overkill, this system. I could have done this in a lot smaller setup and a lot less scalable, but you'll see later on if we decide to copy and paste this, it's quite procedural. So you can just plug in any shape, any model and just tweak as many creatures as you want. And if the model comes in and you want the eyes and the teeth, then this setup will be a little bit more scalable, which you might see later on in either this series or in a separate Vellum series where we do stuff with it. So yeah, this is just going to save away, hopefully, and that's going to be the DC monster publish. So I pop that there. So there it is. So it's just like 3 entry points here to kind of creating this setup. And then I just create the output. So when I return up into Solaris world, you'll have this animated proxy, purpose, and render geometry. And we can then put this into a new component geometry, middle click, called whatever we like, A-Pose01. I'm just toying with the idea. I thought maybe I'd create just one and then I'd do some CFX and have sublayers and then maybe iterate over those sublayers of animation versions. But it's a posed object. So what I'm going to do is try and find a pose that I like and looks interesting, and that can be a pose variant. So this will go in here like so. So I asset merge that in, and then I'm going to freeze the frame, and then I'm going to split this out because at the moment we're feeding in both the proxy and the render purpose. I'm going to split it based on the path. So I'm going to say give me all the render geometry on this side, and I'm going to delete the path, and I'm going to bring out the proxy and delete the path because the new path will be created when it exits this component geometry, and it will create a new path which will be, oh, I have got some layer overrides. It will be, what's that favorites thing there? Get rid of that. It will be the same as if we, I haven't put sim geometry in this one, but it's fine. I'm not necessarily going to use it for simulation in the way that you might think. That sim geo I'd rather create in FX or CFX. But if you were just using like rocks, you could do a sim geometry to like using the edit lop or the drop lop, and you can create basic simulation geometry for like the bullet solver, I think. So there is model A ready to pose, and you can see locked off. So that's all I've done is I've just chosen something here, and furthermore you can click that and you can see the fascia, which was never simulated, has come along for the ride, as you can see. So you don't want to render this animated at this point. This is just for a static thing, because I haven't carried through any velocity or anything like that, so it wouldn't have motion blur and things like that. So I would just like say maybe that's an interesting frame to freeze, and that's my new model. It's my new geometry variant. And in fact, I did a little bit of this for the alien egg thing, where I had 4 models, and I basically just kept dropping and using Vellum to kind of open up the egg. So you had a sphere inside pushing out and different properties, and every time the egg opened, it gave a different model variant and stuff. And I thought that's quite an interesting way of getting a different model variant. So there you go, that's what that is there. So the next thing I've done is I've added the material library now globally to both, like so. And if you remember, we were adding in a material that applied to both the fascia and the skin. And then what I decided to do is do something a bit different and add a custom material for the fascia on this one, and a skin material. So if you go inside, you'll see that there is the Monster A Pink, which is the skin. I'm using it on the skin, and then there's the one for the fascia where I just had to play with some stuff on here. I don't think there's anything worth showing, but you can have a dig around. And this is not a look dev tutorial, that's why my look dev is crap and my modeling is crap. It's more like a workflow that I'm getting in place, so then I can spend the time doing this and not have to worry about all of this confusion. So I just copy and pasted this and renamed it A, and then did this. So Monster B, as you know from the previous one, is the whole shebang. It's just like bringing it in, retopoing and everything like that, and that's just got one material on. There are advantages and disadvantages of doing it this way. So you have less control, like, because you're applying one material which is loading all the textures in a UDIM space. So we know that if you put these into UDIM space, into UV space, one's over here, one's over here, and that's kind of happening. But sometimes you want more control as well. So there's a lot of freedom, and you just have to kind of plan out what you want. But hopefully that's giving you a quick overview. So this is linked into here, and maybe it's the right way, maybe it's the wrong way of working, but it's just a nice way of getting another version out. So you just need to know what this version is for when you're back down in your... I've added a network view here of my TOPS network. So this is looking inside, and it's unlinked, but it's looking inside this, so I can always kind of quickly go through and evaluate what I want to send to a renderer. To the renderer, I can look at the end of this network here, look at my render settings, and there he is. Get rid of the light. That just hides the visibility of the icons, these. Bear in mind, if you turn that off, it does hide your geometry. If you turn that off, it doesn't render your materials. This caught me out when I started doing this, and I lost half an hour of my life figuring out that if you render disk, I think it's fine, but this is just temporarily saying don't put the materials on in the viewport, and this caught me out big time. So when I switch this on, it's going to reapply those materials. So there's the posed monster as well, rendering live. So now it's just a case of picking the monster you want and rendering them all to disk like we did. So but yeah, hopefully this has been a little kind of overview of how I use Vellum to pose something for one frame, static frame. So don't worry about the Vellum thing too much. We're going to go into that a lot more in another series when we start just by modifying the creature with multiple parts and stuff. And we're going to have probably one more variant added in, which is going to be exactly this, copy and paste this in another video, and we'll finalize the whole thing, and we'll have an asset to play with. And the whole thing is open to change. You can always go back in and modify things. So yeah, I hope you found this useful, and I'll see you in the next video. Thanks for your time, everyone. Take care. If you're finding this tutorial useful, why not drop a like and let me know in the comments. And if you're interested in learning more Houdini, hit that subscribe button so you don't miss out on the next tutorial.